Now we'll discuss what is the scalar and vector quantity. What is a scalar, first of all? Actually, scalar, this is the quantity which expressed with the magnitudes only. Now, length of a car is 4.5 meter. Length is the physical quantity, and 4.5 is the magnitude only. So the expression and the quantity which can be expressed with magnitudes only is called scalar quantity. And the mass of a gold bar is 1 kilogram. So physical quantity is mass here, and 1 kilogram is magnitudes. Similarly, time is 12.76. So time is the physical quantity, and this is the magnitudes only. Similarly, temperature is 36.8 degrees centigrade. Here physical quantity is temperature, and magnitudes is 36.8. So first of all, what is a scalar quantity? A scalar is a physical quantity that has only magnitudes. This is the example: mass, length, time, temperature, volume, density, etc. Similarly, what is vector? Now, position of California from North Carolina is 3,600 kilometer in west. Actually, this direction included with that two parts. One is magnitudes and another is direction. So the physical quantity position of California depends on direction and magnitudes. So the quantity which can be depends on direction and magnitudes is called vector quantity. So what is vector quantity? The vector quantity and the quantity which can be expressed with the direction as well as magnitudes is called vector quantity. Similarly, the displacement from USA to China is 11,600 kilometer in east. So here physical quantity is displacement, east is the direction, and 11,600 kilometer is the magnitudes. So the quantity which depends on direction and magnitudes is called vector quantity. So now the definition: what is the vector quantity? A vector is a physical quantity that has both a magnitudes and a direction. For example, position, displacement, velocity, acceleration, momentum, force, etc. Now, representation of a vector. Now, this is the AB is a vector, and the distance will be the magnitudes, and head is B here, and tail is A. This is the angle which indicate the direction. So symbolically, it is represented as AB vector. Okay, with the arrow sign, we can denote as a vector. Now, representation of a vector, they are also represented by a single capital letter with an arrow above it, a vector, B vector, and P vector also. Now, representation of a vector, position vector can be expressed as R vector, and velocity V, and force F. Types of vector on the basis of orientation. This is a parallel vectors, A vector and B vector direction same, but length may be different. Similarly, P and Q also parallel. Equal vectors, the two vectors will be equal. It should be equal in length and direction. So anti-parallel means you must know a vector and the opposite, the direction of another vector will be in opposite of a. Similarly, PQ is the also anti-parallel. Now, negative vectors, what will be? A vector can be expressed as the another vector B with the negative. So A vector and B vector will be equal but opposite. Similarly, P and Q also. Now, collinear vector, A vector and B vector will be collinear if they are two vectors are said to be collinear vectors if they act along the same line. Okay, P and Q and F. Co-initial vectors, two or more vectors are said to be co-initial vectors if they have common initial points. Suppose A vector, B vector, C vectors, and D vectors which pass through the same points. That means the initial points. Coterminal vectors. Two or more vectors are said to be coterminal vectors if they have common terminal points. A vector and B vector, C vector. Then all vectors are meeting at a point, coterminal. Coplanar vectors. Three or more vectors are said to be coplanar vectors if they lie in the same plane. Okay, a vector, B vector, C vector, D vector lie in the same plane. Non-coplanar vector. Three or more vectors are said to be non-coplanar vectors if they are distributed in the this is the coplanar vectors. Three or more vectors are said to be non-coplanar if they are distributed in same space, not in same plane. So this is the non-coplanar types of vectors on the basis of effects. Now polar vectors. Vectors having straight line effects are called polar vectors. For example, displacement, velocity, acceleration, force, etc. Axial vectors. Vectors having rotational effects are called axial vectors. Suppose angular momentum, angular velocity, angular acceleration, torque, etc. So now vector addition geometrically. Triangle law. Suppose Iran, Egypt, and Yemen. We are connecting with Egypt to Yemen and Iran to Yemen is B vector. So if their distance from Egypt to Iran will be indicated by C vector. So C vector can be represented as a vector plus B vectors. This is the triangle law. Similarly, parallelogram law. And suppose a vector, and this is the vector, and another one is B vector. So a vector and B vector acts at a point, same points. Suppose this is the pulley and having the mass m. So if a vector and B vector can be represented as this diagram, like a parallel. So a vector and this is the another parallel, equivalent parallel lines. So this C vector, that means the sum of these two vectors will be indicated as, that means resultant will be the A vector plus B vector. This is the parallelogram law. Similarly, polygons, this is the actually wheel of a car or any vehicle. So at a point, A vector, B vector, C vector, and D vector are coming from the same point. Then after addition will be this addition of these four vectors will be polygon law. We have to use polygon law. C vector equals to A vector plus B vector plus C vector plus D vector. Then with A vector, this is the initial and this is the final point. Adding another second vector with the first. So A vector plus B vector plus same direction. All are same direction, but resultant will be the opposite direction. So E vector equals to A vector plus B vector plus C vector plus D vector. Similarly, vector can maintain the commutative law. A vector plus B vector equals to will be B vector plus A vector. And associativity also maintains in vector. So the addition of vectors obey the associative law. Similarly, subtraction of vectors, A vector plus, minus B vector will be indicated as like this. So A vector minus B vector will be A vector plus addition with the opposite of B. So this is the magnitudes of result or resultant. You must know about this. Resultant R equals to in of A vector of P vector and Q vector can be expressed as root over P square plus 2s PQ cos theta plus Q square. This is the resultant of magnitudes. Now similarly direction can be found like this. Sin theta equals to perpendicular by hypotenuse. So cos theta equal to base by hypotenuse. Similarly, tan means tan alpha equals to perpendicular by base. So base OM equals to what? OA plus M. Just putting the value of OA and M, we can find the direction. Similarly, two parallel vectors. If the angle between them is theta equals to 0 degree, then the magnitude should be the maximum and direction will be 0 degree. Similarly, if theta equals to 90 degree, then magnitude should be root over P square plus Q square, and alpha equals to tan inverse P by Q. If the vectors are anti-parallel, that means theta equals to 180 degree, then the magnitude will be the minimum. So, and if the first vector is greater than the second vector, then alpha equals to 0, and the first vector is less than the second vector, then including angle will be 180 degree. This may be indicated as force also. So unit vector, what is unit vector? Unit vector is a vector that has the magnitudes of exactly 1 and drawn in the direction of a given vectors. Okay, a vector and another vectors. It lacks both dimension and unit. Its only purpose is to specify a direction in the space. Unit vectors, you must know the unit vectors. A given vector can be expressed as a product of its magnitudes and a unit vector. For example, a vector can be represented as like this. Cartesian units of vectors, you must know, along the x-axis I, along the x-axis I, along the y-axis is z, and along the z-axis is the k. So I, j, k, this is the red color and green. So these three colors indicates the unit vectors along the x-axis, y-axis, and z-axis. So resolution of vectors, you must know, it is the process of splitting a vector into two or more vectors. From one vectors, we can split into it into two parts. One is n, another is at. So along the t, at, and along the n, n. So one vectors can be expressed in or represented into two or more vectors. So rectangular components of 2D vectors, you must know, vectors can be represented as x along x-axis and along y-axis. Ij is the unit vectors. Similarly, we can find the angle also using sin theta equals to sin theta equals to base by hypotenuse. So cos equals to perpendicular by hypotenuse, sine, and base by hypotenuse is cos. So we can find the value of x vectors, and another one is ay vectors. Magnitude and direction from components, a vector can be represented as like this. Magnitudes will be root over x square plus ay square, and angle will be tan inverse ay by x. This is the resultant along x-axis and the resultant along y-axis. This is called also upangsha. X-axis is upangsha and y-axis is upangsha. This is the magnitudes man and direction b. Rectangular components for 3D vectors, you must know this is the x along x-axis, y along y-axis, and az along z-axis can be represented as like this: a vector equals to x vector, a y vector, and plus a z vector. So similarly, in 3D vectors, the direction can be always like this. Now, rectangular vectors, components of 3D vectors, can be represented as along the y-axis, a cos beta. Similarly, on z-axis, z equals to this. Now, magnitudes and direction from the components, you must know magnitudes can be represented as a vector equals to root over x square plus y square plus az square, and direction will be this: alpha equals to this, beta equals to this, and z gamma equals to this. Now, adding vectors by components, you must know a vector and b vector can be take the resultant r equals to a vector plus b vector. Okay, just adding. Now, multiplying vectors, multiplying a vector by a scalar, and multiplying vector by a vector also. So there are two types of multiplication here. Now, if s is the positive, then 2 times will be like this. If s is negative, 3 times will be like this. Just opposite of a, because negative. Now, multiplying a vector by a vector, these are two types. One is dot product, and other is cross product. One is the dot product depending on cos theta, and cross product depending on sin theta. This is the scalar product. The example of a scalar product is work done. Work done equals to what? Displacement multiply force. So a vector dot b vector equals to ab cos theta. Okay. And this is the example of a scalar product. This is the work done, force, dot product, displacement. So work done, force, displacement. Similarly, power, force, velocity. Okay. The geometrical meaning of a scalar and vector product. Now, vector product can be represented as the projection of A on B vector. Okay. Properties of the scalar product: a dot b equals to ab cos theta and b dot a equals to ab. So maintain the associative commutative law. Similarly, three properties of this is also another properties. Number three properties. The scalar product of two perpendicular vectors is 0. Cos 90 degree equals to 0. This is why it would be equals to 0. So similarly, the scalar product of two parallel vectors will be cos 0 equals to 1. This is the maximum positive. Similarly, the maximum negative will be at anti-parallel. That means 180 degree, including angle will be 180 degree. Cos 180 degree equals to -1. This is why it would be equals to minus AB. This is the maximum negative. Similarly, the scalar product of a vector with itself is equal to the square of the magnitudes. Okay, that means same vectors. If we take the dot product of same vectors, okay, then it will be a square. Similarly, I dot I, Z dot Z, K dot K equals to 1 because I dot I means what? Including angle 0 degree. So cos 0 degree equals to 1. This is why 1 into 1. This is the unit vector. This is why 1. Similarly, I dot Z, Z dot K, K dot I equals to 0 degree because they are perpendicular to each other. Now calculating the scalar product using components, A dot B will be what? Just multiplication. And you must know I dot I, Z dot I dot Z equals to 0, I dot K equals to 0. In this, using this relationship, we can find the A dot B equals to AX BX plus AY BY and AZ BZ. Now, another important product of vector is vector product. So depending on sine theta, A cross B equals to AB sine theta. This theta indicate the direction of the vector product. This is indicated as C vector. Now, how do we indicate the vector, the direction of vector product? This is the right hand rule. At including angle will be theta, but the resultant will be the C. So direction will be like this, right hand rule. Similarly, torque is the example of the vector product. Torque is the you must know torque equals to position vector vector product with the force. So tau equals to torque equals to R at sin theta. This theta indicates the direction of tau. That means similarly, angular momentum L equals to what will be position angular or radius multiply P. P means linear momentum. So L can indicate RP sin theta theta. Theta is the actually indicate the direction. Similarly, geometrical interpretation, we can actually the vector product, the magnitudes of a vector product will be the area of the parallelogram made by two vectors. Similarly, properties of vector product, A cross B equals to AB sin theta. So B cross A equals to minus AB sin theta. This is why it cannot maintain the commutative laws. Now, properties 2, vector product is the vector product is distributive over addition. Okay. Similarly, A cross B magnitudes of the vector product will be AB sin 90 degree. 90 degree means what? This is the 1. So this is the maximum. So two perpendicular vectors gives the maximum magnitudes. Similarly, the vector product of two parallel vectors is a null vector because sin 0 degree equals to 0. This is why this is the minimum. Now, property 5, the anti-parallel vectors will be indicates the A cross B equals to also 0. Similarly, the vector product of a vector with itself is a null vector. Okay, A cross A equals to A sin, because the including angle is 0 degree. This way sin 0 equals to 0. This way 0. Property 7, I dot I, Z dot Z, and K dot K equals to actually 0. Similarly, I dot I cross Z equals to K, Z cross K equals to I, K cross I equals to Z. But if they are, because the vector product cannot maintain the commutative laws, this is why Z dot I will be minus K, K dot Z equals to K cross Z equals to minus I, and I cross K will indicate minus Z. So remember this I, Z, K. This is the actually sequence for counting I, Z, K. But if this circle or represented like this, then it the anti sequence, then it will be indicated as minus here. Okay. So calculating cross product of two vectors, just putting the values of this one, we can find the calculation of the product of two vectors. Now calculating the product of three vectors, two vectors, one is across B equals to this. This is actually determinant of Isaac, X, Y, Z, and B, X, B, Y, B, Z. This is the first vector, second vector. Components of first vectors is the second row, and second vector will be the third. So this is actually this is the complete description with a real life example of that. So from this part, we can define what is a scalar quantity. Physical quantities which can fully expressed by magnitudes only are called scalar quantity. So length, mass, speed, work, energy, time, etc. Are the example of scalar quantity. Similarly, vector quantity, what should be physical quantities which need both magnitudes and direction to be fully expressed. It's called vector quantity. Now displacement, weight, velocity, acceleration, force, etc. are the examples of vector quantity. What is the difference between scalar quantity and vector quantity? You must know about this vector quantity. And now what will be the speed and velocity? Motion in physics, motion is a change in position of an object with respect to time. So what is motion? This is the definition of motion. Motion in Bangla, goti. Change in action is the result of an unbalanced force. Motion is typically described in terms of the velocity, acceleration, displacement, time, etc. Now, what is linear motion? Also called rectilinear motion, is a motion along a straight line and can therefore be described mathematically using only one spatial dimension. For example, a linear motion is that of a ball thrown straight up and falling back straight down. In physics, circular motion is rotating along a circle and a circular path or a circular orbit. It can be uniform, that is with constant angular rate of an object, and non-uniform, that is with a changing rate of rotation. Rest. What is the definition of rest? A body is used to be static or at rest with respect to surroundings when it does not change its position with time. So rest means sthir. Motion. A body is said to be in motion with respect to surroundings when it changes its position with time. Then this change of position with respect to time is called motion. Displacement, Sharon Kakabole, the change of position of an object with respect to its surrounding in a definite direction is called displacement, which is denoted by the dimension is capital L, unit is meter. Now, what is the speed and velocity? The speed is a scalar quantity that refers to how fast an object is moving. So speed can be thought of the rate at which the object covers the distance. So an object with no movement at all has a zero speed. Now what is the velocity? Velocity is a vector quantity that refers to the rate at which an object changes its position. So velocity is a vector quantity. Now what is speed? The rate of change of position of a body with time is called speed. Speed is a scalar quantity. So speed equals to what? Distance by time. B equals to d by t or h by t. Dimension will be L per t, and speed, unit of speed will meter per second. Now what is velocity? The velocity of a body is the rate of change of displacement with time, that is distance traversed by a moving body in unit time in a definite direction is called the velocity of the body. So velocity is a vector quantity. B equals to what? Displacement by time or distance by time. Dimension will be L per t, and dimension all, remember that dimension always expressed with capital letters and units with small letters. Unit will be meter per second. This is actually difference between speed and velocity. Okay, you must know. গতি এবং বেগের মধ্যে পার্থক্য. Now, what is the acceleration? Acceleration, the rate of change of non-uniform velocity of a body with time is called acceleration. So if the initial velocity of a body is u and final velocity is v, then the change of velocity in time t will be v minus u. So rate of change will be what? V minus u by t. The rate of change of velocity is the actually acceleration. So I equals to v minus u by t. So unit will be what? Rate of change of non-uniform velocity is called acceleration. This is for velocity unit divided by time, meter per second square. Now, equation of motion. First equation, v equals to u plus at. V equals to final velocity, u is the initial velocity, a is the acceleration, and t is the also time. So, a relation bit among final velocity, acceleration, and duration of time. So, let a body with initial velocity u in uniform acceleration a. Let the final velocity is v. So, the change of velocity in time t is v minus u. We know that the rate of change of velocity is the acceleration. So, I equals to v minus u by t, and by cross multiplication, v minus u equals to at. So, b equals to u plus at. So, b equals to what? Final velocity, u equals to initial velocity, a is the acceleration, and t is the time. If there is no initial velocity, then u equals to 0. In that case, putting u equals to 0 here, b equals to at. So, second equation of motion, relation among displacement, final velocity, and duration of motion. S equals to what? U plus v divided by 2. This will be 2 actually. This will be 2, v plus u by 2 into t. Now, let a body with initial velocity u moves a distance as with uniform acceleration. Since the body moves with uniform acceleration, the average velocity will be the average of initial and final velocity. Average equals to what? U plus v by 2. So, we know average velocity equals to what? Displacement by time. So, s by t. S by t equals to what? U plus v divided by 2. In this case, s equals to what? Displacement equals to u plus v divided by 2 into t. This will be 2. Remember that. Now, third equation will be what? S equals to ut plus half at square. And let the initial velocity of a body be u and uniform acceleration is e. Let it attend the final velocity be in time t. Let it describe or distance as during time t. The displacement is s, then the average velocity b of the body will be b equals to s by t. So by cross multiplication, s equals to b bar t. Okay. Again, the body is moving with uniform acceleration. The average velocity will be b plus u by t. Just putting the value of b bar here. Actually, this will be also b bar. Okay. So we get s equals to b plus u by 2 into t. Now, again, we know that the rate of change of non-uniform velocity is called acceleration. So a equals to b minus u by t. In that case, b equals to u plus a t. Just putting the value of b in equation 3. This is the equation 3. Okay. Just b plus u by t. Now, fourth equation, b square equals to u square plus 2s. Similarly, you can also derive this equation. That the initial velocity is u and uniform acceleration is a. This is actually a printing mistake. And final velocity is b. Then the body describes a distance s in time t. The mean velocity will be, average velocity will be b bar equals to s by t. So s equals to b bar t. Now, again, the body mass, since the body masses with the uniform acceleration, which means the velocity will be the arithmetic mean of the initial and final velocity. So b bar equals to u plus b by 2. Now putting the value of b bar in equation 1, we get this relation. Again, we know that the rate of change of non-uniform velocity is the called acceleration. Equals to b minus u by t, t equals to b minus u by a. Just putting the value of t in equation 3, we get u plus b equals to 2. Remember this is the printing mistake. This is the 2. B plus u plus b divided by 2. Okay, this is not t. So what is momentum? Momentum is the product of the masses of a body and its velocity. If the masses of a body is m, the velocity b, then the momentum can be expressed as p equals to m. It's vector quantity, and this is the dimension of momentum, and this is the unit kg, meter per second. Now, what will be the force? You must now Newton's laws of motion. You must know the laws of motion, inertia, and this is the Newton laws of motion. In 1687, Sir Isaac Newton gives the laws of motion. First law: everybody continues in its state of rest or of uniform motion in a straight line until an external force is applied to its body. That means what? এই মহাবিশ্বের প্রতিটি বস্তু স্থির থাকবে এবং গতিশীল বস্তু গতিশীল থাকবে যদি না আমরা বাইরে থেকে একটা ফোর্স অ্যাপ্লাই না করি। দিস ইজ দ্য ফার্স্ট ল অফ মোশন। Second law: the rate of change of momentum of a body is proportional to the applied force, and it takes place the direction of the straight line along which the force acts. This is the second law. বলবেগের পরিবর্তনের হার প্রযুক্ত বলের সমানুপাতিক এবং এই বর্বে যেদিকে ক্রিয়া করে বর্বেগের পরিবর্তনও সেদিকে ঘটে। This is the second law of motion. Now third law that to every action there is an equal and opposite reaction. So প্রত্যেক ক্রিয়ারই একটা বিপরীত ইকুয়াল এবং বিপরীত প্রতিক্রিয়া রয়েছে। Now another is inertia, the tendency of a body to preserve in its state of rest or of uniform motion for all time to come, or the property to preserve its state is called inertia of body. কোনো বস্তু স্থির থাকতে চাওয়া অথবা গতিশীল থাকতে চাওয়া যে প্রবণতা সেটাকে বলবো আমরা ইনার্শিয়া। There are two types of inertia of rest and inertia of motion. The tendency of a body at rest to remain at rest is called the inertia of rest. Inertia of rest, and this is the example we must know. কোন একটা গাড়ি যখন স্থির থাকে তখন হঠাৎ করে চলা শুরু করলে আমরা কিন্তু পেছনের দিকে হেরে যাই। পেছনের দিকে হেরে যাওয়াটা হচ্ছে inertia of rest. Okay. Inertia of motion, the tendency of a body in motion to keep the motion uniformly for all time to come is called the inertia of motion. গতি জড়তার একটা এক্সাম্পল হচ্ছে কোন গাড়ি চলমান গাড়ি হঠাৎ করে ব্রেক করলে তখন আমরা সামনের দিকে ঝুঁকে যাই। তার মানে গাড়িটা গতিতে ছিল, আমরাও গতিতে ছিলাম, তা আমরা গতিতে থাকতে চাইছিলাম, এই জন্য আমরা সামনের দিকে ঝুঁকে পড়ছি, সেজন্য এটার নাম হচ্ছে গতি জড়তা, inertia of motion. The tendency of a body in motion to keep on motion uniformly for all time to come is called inertia of motion. So you must know F equals to ma, force equals to mass multiplied acceleration. Let a body of mass m moves with uniform velocity u, initial velocity, or constant with a constant force F acting on a body in the direction of velocity for a time t. Increases the velocity, let the velocity after the time t will be v. That means final velocity. So initial momentum equals to mu and final momentum mv. Change of momentum, rate of change of momentum with time t will be mv minus mu. So rate of change of momentum would be mv minus mu divided by t. M common, but acceleration equals to b minus u by t. This is square, just putting this value b minus u by t equals to a. So we get ma. But according to the Newton's second law, the rate of change of momentum is proportional to the applied force. Okay, ma proportional to f. So ma equals to what will be kf. K is the constant proportionality. If we take m equals to 1 kilogram, a equals to 1 meter per second square, then we get the definition of Newton. So what is Newton? If any body has 1 kilogram mass and their acceleration is the 1 meter per second square, then these types of the amount of force is called 1 Newton. So putting the value of K in equation 1, then we get the force equals to ma. So laws of motion, actually laws of inertia also equals to ma and action reaction. And Newton's law says many people do not know what they mean or simply do not to believe what they mean. So Newton's laws of motion, first law is this: an object at rest will stay at rest, and an object in motion will stay in motion at constant velocity unless another external force is applied to it. So second law, the force equals mass times acceleration. Third law, for every action there is an equal and opposite reaction. Now first law of motion, it is also called laws of inertia. An object at rest will stay at rest, and an object in motion will stay in motion at a constant velocity unless acted upon by an unbalanced force. So this is the first law. Inertia is the tendency of an object resist changes in its velocity, whether in motion or motionless. These pumpkins will not move unless acted on by an unbalanced force. So if we take away a pumpkins, then we all will move. Another one is first law: once airborne unless acted by an unbalanced force, gravity or air fluid friction, okay, it will never stop. Another example: unless acted upon by an unbalanced force, this golf ball would sit on the tee forever. So this will not act it. Otherwise, if we don't apply any force. So why then we do observe everyday objects in motion, slowing down and becoming motionless, seemingly without an outside force. Object on Earth, unlike the frictionless space the moon travels through, are under the influence of friction. Friction means torsion. So what is the unbalanced force that acts on an object in motion? Now, there are 4 types of friction. One is sliding friction, rolling friction, fluid friction, static friction. Sliding friction means ice skating. You must know about this. Rolling friction is bowling. Fluid friction, air or water resistance. And static friction will be initial friction when moving an object. Sliding a book across a table and watch it slide to rest position, the book comes to a rest because of the presence of a force. That force being the force of friction, which brings the book to a rest position. This is the example of friction. Now, Newton's first law and you. Suppose you are driving a car, and don't let this be you wear seat belts. Because of inertia, objects, including you, resist changes in their motion. When the car is going 80 km per hour, is stopped by the brick wall, your body keeps moving at 80 meter per hour. This is why there will be an inertia here. Now, second law, F equals to ma. You must know about this second law. The net force of an object is equal to the product of its mass and acceleration. F equals to ma. F means force and product of mass and acceleration. So this is also called the rate of change of momentum is called is proportional to the applied force. Okay. Now second law, when mass is in kilogram and acceleration is in meter per second square, then the unit of force is the Newton. Remember. So 1 Newton is equal to the force required to accelerate 1 kilogram of mass at 1 meter per second square. So second law, how much force is needed to accelerate 1400 kilogram car 2 meter per second square? Write the formula F equals to ma and fill in the given numbers with it. Then we get the solve the problem. This will be 2800 Newton. Okay. Now you must know net force, mass in kilogram, acceleration. So net force will be 10, mass kilogram 2, and acceleration will be F equals to ma. Just applying F equals to ma. Now the second law proves that the different masses acceleration to the earth at the same rate but with different forces. We know that objects with different masses accelerate to the ground at the same rate. So 10 kilogram mass and this falling. So the falling the acceleration due to gravity will be 9.8. This is why 98 Newton. Now you can calculate this by the equation F equals to ma. M is the acceleration here for the falling bodies. পড়ন্ত বস্তুর ক্ষেত্রে acceleration হবে acceleration due to gravity. That means acceleration due to gravity means what? This will be অভিকর্ষজতা. Okay. So 9.8 equals to, you must know, 1 kilogram in 9.8, 1 meter per second square. Now, now about the Newton's history of discovering these laws. Check the understanding. What acceleration will result when a 12 Newton net force applied to a 3 kilogram object? a 6 kg objects. This you can solve easily. Okay. Now, force is the push or pull that causes the change in the motion of an object. Okay, this is the gravity and this is the electricity, static electricity. When you rub with a comb, your hair will be electrified with the static or electrons. So this static electricity will be produced there. And this is also friction. Due to friction, this is the magnetism. Now, third law, for every action, there is an equal and opposite reaction. According to the Newton, whenever object A and B interact with each other, they exert forces upon each other. When you sit in your chair, your body exerts a downward force on the chair, and chair exerts upward force on your body. So, third law, there are two forces resulting from this interaction: a force on the chair and other force is in your body. So, when you sit down with a chair, then these two forces are called action and reaction. যখন তুমি কোনো একটা চেয়ারে বসে থাকো, যখন চেয়ারও তোমাকে একটা ফোর্স দিচ্ছে আর তুমিও একটা ফোর্স দিচ্ছ, ইকুয়াল এন্ড প্যারালাল, এই জন্য তুমি বসতে পারছো। নাহলে কিন্তু তুমি সহ চেয়ার সহ মাটিতে ঢুকে যেতে। এই জন্য তুমি যে ফোর্সটা দিচ্ছ এটা অ্যাকশন, চেয়ার যেটা দিচ্ছে সেটা হচ্ছে রিঅ্যাকশন। Newton's third law in nature, consider the propulsion of a fish through the water. A fish uses its fins to push water backwards. In turn, the water reacts by pushing the fish forward, propelling the fish through the water. যে মাছ যে কিভাবে চলাচল করে সেটা। The size of force on the water equals the size of the force on the fish. The direction of the force on the water is opposite to the direction of the force on the fish. Now, flying gracefully through the air, birds depends on Newton's third law. This is actually another real life example of Newton's third law. And as the bird push down on the air with their wings, তাদের wings দিয়ে পাখা দিয়ে যখন এয়ারকে একটা ফোর্স দেয়, the air pushes their wings up, তখন এয়ারও একটা ফোর্স দেয় and gives them lift. তারা উঠতে পারে। When consider the flying motion of a bird flies by wings. The wings of a bird push air downwards. In turns, they are reacts by pushing the bird upward. So this is the real life examples of Newton's third law. Other examples of Newton's third law: the baseball force the bat of the left, the bat forces the ball to the right. So this is the one is action, another is reaction. Another one, consider the motion of a car on the way to a school. A car is equipped with wheels which spins backwards. As the wheels spins backwards, the grip the roots and pulls the root backward. Another one, the reaction of a rocket in application of third laws of motion, airplane, rocket, etc., using third laws of motion. So this is another example of Newton's third law. So Newton's laws of motion also have another real life example. An object at rest is at rest unless an external unbalanced force acts on it. So the Newton's first law of motion applies to the both objects in motion and objects at rest. So this is the example when you're sliding in a park. This is the actually example of inertia for Newton's first law. So this first law also called the laws of inertia. Second law of motion also, this is the laws of acceleration also. And we also have F equals to ma, we have discussed this. And for every reaction there is an equal and opposite reaction. This is also another example. Let's study rocket works to understand Newton's third law. This is the action. Rockets going out the giving out the gases, and due to this action, reaction will be here. So this is the rocket. Reaction will be moving towards the direction, and this is the backward direction. The rocket action is to push down on the ground with the force of its powerful engine, and the reaction is that the ground pushes the rocket upwards with an equal forces. So this is another example. So we have discussed, we have review of this Newton's laws of motion. This is the background of discovering Newton's laws of motion. English scientist and mathematician famous for his discovery of laws of gravity. So discovered the 3 laws of motion. Today these laws are known as the Newton's laws of motion. So this is the quote of Newton's, Sir Isaac Newton's. And this is the 3 laws. Number 1 laws, this, what does this means? Actually, basically, we have discussed this one. An object will keep doing what it was doing unless acted on by an unbalanced force. So what is meant by unbalanced force? This is the meaning of the force on the book are unbalanced. The table pushed upward on the book, gravity pushed him downwards on the book. And another example in our real life. A saucer ball is sitting at rest. It takes an unbalanced force of a kick to change its motion. So this is another real life example. 2 teams are playing tug of war. They are both exerting equal force on the rope in opposite direction. This balanced force results in no change of motion. Newton's first law is also called the laws of inertia. We have discussed it. Inertia means this, the tendency of an object to resist changes in its state of motion. And first law. So the more example in our real life, powerful locomotive begin to pull a long line of a boxcars that were sitting at rest. Since the boxcars are so massive, they have a great deal of inertia and it takes a large force to change their motion. Once they are moving, it takes a large force to stop them. অনেক বড় লরি তখন এটাকে সরাতে হলে অনেক বড় ফোর্সের দরকার। So another one, on our way to school, a bug flies, একটা মাছি যদি বা একটা মৌমাছি যদি fly করে into our windshield. Since the bug is so small, it has very little inertia and exerts a very small force on your car, so small that you don't even feel it. Very important, interesting example. Okay, a book is sliding across a table, slows down and stops because of their force of friction. If you throw a ball upwards, it will eventually slow down and fall because of the force of gravity. Another one is in our outer space, away from the gravity and any source of friction, the rocket ship launched with a certain speed and direction would keep going in that same direction and at that time speed forever. Newton's second law, we have discussed in Apple's timing. Acceleration, a measurement of how quickly an object is changing speed. This is the, what does it mean? So if you double the mass, double the forces. If you double the acceleration, you double the force. Okay. Now what does it F equals to ms means? Something very massive, high mass that's changing speed very slowly, like a glacier, it can still have great force. This is the example. Sometimes very. So Fa equals to ma basically means that force of an object comes from its mass and its acceleration. Something very massive, high mass, it's changing speed very slow, low acceleration, like a glacier. It can still have a great force. Sometimes very small, low mass that's changing speed very quickly, high acceleration like a bullet. Okay, should এটা গুলি এটা কিন্তু speed বেশি but mass খুব কম. They can still have a great force. Something very small changing speed very slowly will have a very weak force. So this is another example of second law. Now third law, for every action there is will be equal and opposite reaction. What does this means? Actually, we have discussed this meaning. Now think about this. What happens if you are standing on a skateboard or a slippery floor? Push against a wall, you slide in the opposite direction. So another example of this is the slippery. In rainy season, we always face this problem. Why does it hurt so much when you stub your toe? When your toe exerts a force on a rock, the rock exerts an equal force back on you too. The harder you hit your toe against it, the more force the rock exerts back on your toe. That means আমরা যে একটা পাথরকে যখন আমি পা দিয়ে একটা ফোর্স দেব, পাথর আমাকে কিন্তু ইকুয়াল একটা ফোর্স দেবে. This is the review. Newton's first law, Newton's second law, Newton's third law. Inertia means the tendency of an object to resist changes in its state of motion. Acceleration is this also. Force, velocity. So from this point of view, Newton's laws of motion, we have to discuss about force and mass. Actually, force means what? Push or pull required to change an object's motion vector, show magnitudes and direction. And so four forces known in the universe. One is electromagnetic force, strong force, gravitation, weak forces. You must know about the force unification theory. Three forces unified. Dr. Abdul Salam from Pakistan, he got a Nobel Prize for that. Three forces unified. This is the force unifying theory. Now another force is the actually gravitational force. This is a very weak force. So this four force will be very important in physics. Now there are two main types of forces. One is contact, another is field. Field force, this one, and contact force, this. Now contact force what exists when an object from the external world touches a system and exert a force on it. Think about a book on a table. You'll understand this. Contact force will be acted along that. Another one is an object can move without something directly touching it. Gravitational force is a field force. And can you think another field of forces? Magnetic fields, electric fields, nuclear fields, etc. Now examples of contact force: friction and tension. So mass equals to inertia also. This is the example of what in mass is immeasurable of an object with inertia. This is the example. Okay, and this is the also application of Newton's third law and second law also. Now this is the background of Newton's laws of motion. This is the first law. This is the application, real life example. Now, what means by the unbalanced force? You must know. We have discussed it also. Okay. Now, what is gravity and gravitation? Actually, gravitation or gravity is a natural phenomenon by which physical bodies attract with a force proportional to their masses. Gravitation is most familiar as the agent that gives weight to objects and with mass and causes them to fall to the ground and drop. So the definition of gravitation and gravity in the solar system, the attraction between any two bodies except the Earth and any other bodies is called gravity. For example, attraction between the sun and the moon is gravitation, and but between the Earth and the book is gravity. So gravity is itself a kind of gravitation. Now Newton's laws of gravitation. Newton's laws of gravitation states that every point mass in the universe attract each other with a mass, with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Suppose two bodies of masses m1 and m2 are suspended from each other by a distance d, then if their force is between these two bodies with force is m, so F is the force attraction between them according to the laws of gravitation. Force is proportional to the m1 m2 divided by d square. So F equals to capital Z m1 m2 divided by capital Z is the universal gravitational constant, where F is the force between the masses. This is the gravitational constant. M1 is the first mass, and m2 is the second mass. For the distance between the masses, value capital Z equals to 6.673 into 10 to the power minus 11 Newton meter square per kg square. So here, acceleration due to the gravity is Z. The rate of change increase of velocity of a freely falling body on Earth due to force of gravity is called the acceleration due to gravity. It is denoted by Z, and standard value of Z is 9.80665 meter per second square. The value of Z in the polar region is 9.83217. So this is the, now what is the mass? Mass is the measure of the amount of material in an object, and weight is the gravitational force acting on a body of mass. Transforming the second laws of motion, we can find the weight equals to mc. M equals to mass of a body, and C is the acceleration due to gravity. Okay. Now work, power, energy. Actually, the work done on an object is the product of the average force on its and distance traveled in the direction of the force. Work equals to what? The product of the force and displacement of a body application along the direction of the force is called work. W equals to Fs. Dimension is this, and unit also this. The power will be also this. The work done by a person or a source per unit time is known as power. So power equals to work done divided by per unit time. This is the same with energy. The capacity of doing work of a body is known as the energy. Energy is a scalar quantity, and dimension is the same as the power. So dimension equals to m square per t square. This is the unit of dimension of force. And form of energy, there are two form of energy is 9 form. Mechanical energy, heat energy, sound energy, light energy, magnetic energy, electric energy, chemical energy, nuclear energy, solar energy. The mechanical energy are two types: potential energy, kinetic energy. This is the definition of potential energy. So potential energy equals to mg's. M is mass, g is acceleration due to gravity, and is the vertical height. Similarly, kinetic energy, you can also find out the value of kinetic energy. This is the actually half mv square. The principle of conservation of energy: every energy can neither be exerted or destroyed, but it can be transferred from one form to another form. It is called the principle of conservation of energy. The total energy of the universe is constant and unchangeable. Okay, various types of gravitational and potential energy. Okay.